Hi everyone, I'm Pepa. Thank you for having me in Amsterdam. It's a great city, by the way. I really like this. It's my first time here. And I'm here to talk about functional programming in C#. And yeah, what's that about? So a little bit about me. As I always say, I'm just another guy with GitHub and Twitter as everybody else. I'm from Czech Republic, from a company called Muse. We are a global company. We do software for hotels, and I'm something like a lead architect there. So yeah, I guess that's enough about me. I'm not that interesting. So why would I talk about C# when you have F#, right, in the .NET environment? But let me ask you, so that I know who I'm speaking to, how many of you know functional programming? If you can raise up your hand, okay? And then please keep your hand up if you are a functional programmer that you really feel you do. Okay, great. Who among you tried F#? Okay, who tried it more than one day? 2 days? Okay, those are the survivors. Okay, so as you can see, there is not many F# programmers in community. Or have you tried Haskell? Who tried Haskell? There's more than F#. That's pretty nice. Okay, but there is generally not many guys doing F# or Haskell like in a job or something. So and the market is tough. Like hiring developers even for C#, it's pretty hard. So hiring developers for F# is even harder. So that would not be a good way to go. And another thing is, like, we are usually not on a real field, right? We have some big code base written already in C# possibly. So like starting out with F# is pretty hard. And so at Muse we took like another road. We will go with C#, it's a good language, and we will kind of incorporate the functional concepts there and teach it to the people who have never heard it, like gradually. Okay. So what really is functional programming about? It's really hard to define what really is a functional program, which is object-oriented programming. And it basically goes down to something which is called referential transparency. So yeah, there is one disclaimer. Functional programming is known for a lot of big, crazy, scary words. One of them is referential transparency. So what it really means is that if you call a function with some arguments and you know the argument, you can replace it with the return value. It means that the function does nothing else than return something to its output. And you probably, no, this is not the slide. Okay, it is. You probably know the function more as like a pure function. It's not the same as referential transparent, but you can imagine like that. So the pure functions don't really mess up with the state. And why would you want that? Why it's like important to have this property in your code is that basically there are no surprises. You like, how many times it happened to you that you were like, oh, I didn't figure out this function sends email, or I didn't figure out this function talks to a database or something like that, or changes the state in a weird way. So there are basically no surprises. Also, the testability is super easy. You just put the values you want there, it gives you an output, and you assert the output is what you want it to be. But really, the core feature is that there is no time or state factor. How many of you read a paper called Out of the Tar Pit? Or how many of you know it? Great. So really, they talk about software complexity and what's the main reason why software is complex, and it's the state. Like the state factor, it's the hard part, and that's why functional programming basically tries to tackle it by pushing the state to the bounds and having the core pure. And it really is easy to reason about this because you don't have to have like the global state in mind. You just look at the function, you can reason about the single function individually. Then it's also easy to parallelize, right? Because the parallelization is hard when you have the shared state. And it's easy to cache because the function is deterministic, so it always returns the same thing, so it's not hard to cache it. Yeah, but as I told you, it's hard to define what really is FP and OOP and stuff like that. So I'm not going to show you like functional programming because I don't really know, or it's hard to define, and the two of those can overlap. So you can still, as we, stick to your like object-oriented code base in the big, and you can just try and use these concepts like from the ground and incorporate it into your big code base to improve it. So most of the concepts are doable in like OOP languages or with an OOP code base, but they usually go with the functional programming. So let's see if we can do that. Is C# good enough to give us the tools to do the functional programming? Well, we have functions, like that's already a pretty good start for functional programming. We have several features which makes like programming in C# possible in a functional way, but still there is some stuff that's missing. So we have to help us out with the library, right? So there are two libraries. I'll talk about the first one because we wrote it. But there is this other one, which is called language extension. Who knows language extensions? Okay. It's a really big library written by a guy from Haskell community, and it's super, super big. And basically, starting up with this library is as hard as starting out with Haskell. The learning curve is really steep, and that's what Func# is not about. Func# is really a lightweight library. We made some other decisions, so it's a good choice between it. But I think the Func# is better for start, but with starting out with functional programming. The language extension is something that you can evolve to, in the final stage. But Func# should hold up to most of your functional stuff you want to do in C#. So yeah, let's dig into these concepts, techniques, and patterns that I want to talk about. And I'll kick off with expressions. So you see this code? It's shitty, right? So what's about this code is that it uses statements. So there is some state which is basically not global but can be viewed as global. Then you have if something, change the result to 1, something else, well, you would not write it. You basically all would do this, right? And this is what expression is. The expressions are composable, they are pure, because statements don't return anything. So that means they usually mutate stuff. That's why we don't use them. And they are hard to compose, because stuff that does not return stuff, you really cannot compose it with other stuff. And functional programming is really about composing stuff. And yeah, so we solved the first the if and else with the ternary operator. But what about this? Try and catch, there is no expression way how to write a try and catch. So you have probably all seen some code like this, and it's not nice. We will get rid of that during the talk. Yeah, immutability. So I guess you know that one. So immutability is a great property of that nothing changes. So basically, when you have a function like a printer of a person, you have no guarantee that the printer won't change the person, right? It would be a silly implementation, but I guess we have seen some of those. So basically, everything can be mutated, and it adds to this state factor and everything else. So by immutability, you make the person not mutable, and then we can really trust that nothing will change. And there is also this that people are yeah, but it's a waste of memory. It does, or sometimes people say that it's not important, but actually sometimes the immutability is even more performant than mutable stuff. Let's say Git. Git is also not written in a way that it's basically immutable. You only add the changes, and from the changes you build up the whole structure. If you would do it in an object-oriented way, you would have to basically do a deep copy of the objects, of the code base all the time. And there are even graphical algorithms that really rely on immutability. So it's a really good thing to do even in non-OP languages. And how we do that in C#, we just write a class with only a getter. And then the objects, those objects usually have this pattern called copy on write, where you have this with email, and you basically put a new email address there and it returns a new person. And you always know when you reference to something that it's the same stuff. It has never changed, so it's good for like parallelization, and also like the functional data structures which are immutable are smart. So when you have a list and you add a single element at the end, it's not like that the list is copied all the way. It's only they do stuff which is called structural sharing, that they share the structure, and it's basically a single element with the pointer. I'm a new version. The rest is the same. Yeah. Now we are getting to more like good stuff. So algebraic data types, also a scary word, but that's like, I guess if you can take something from this talk, take this. Like this is the most crucial functional feature, and those are algebraic data types. So what are they? Well, even OOP programmers, they use inheritance. They started to say stuff like composition over inheritance, right? So algebraic data types are just composable types. There are two of them, product and a coproduct. Product basically is an array tuple, which you know, where you have the AND relationship, but the coproduct is stuff that's usually new for people, and that's the OR type. So yeah, the product is really simple. You just say that you have something and something and something. That's basically a tuple. So then you have a point, you have like an x and y, so that's a product of two integers. And yeah, you can basically use system.tuple for that. And even like a product of a single thing is useful for aliasing of the types. When you want to say like that you have a string, but you want to say like a type mail address, you say that the mail address is a product of one, because it will add you like a structural equality and proper implementation of get hash code and stuff like that. But coproduct is the interesting part. So let's say you have this paragraph reader and it can read something. What is probably the return type of the read, right? You don't really know. And even if you look at the .NET implementation of the car reader does not return a single character. It returns an integer in order to say to you that if it's like -1, it's the end. It's really hard to distinguish like for this kind of stuff, and you don't really know what this returns. So in a coproduct, you say it returns either this or that. So whereas in the product example, we have like the AND relationships, here we have the either relationships. So we can say that the read result is either a line or a paragraph end or a document end. It didn't fit there. And then you have like nicely documented what it returns, and it won't allow you to touch like the other branches of the coproduct. You basically have to do something like a switch on it and see like if the single cases, I'll show it later. So that's nice. You can basically think of it as a single level, non-extensible inheritance, right? But that's the good part about it. It forces you to compose the stuff. You cannot really inherit it. You have to put it in. And it's easier to add the behavior, because then, I have the example here, I think. Yeah. Okay, I'll talk about it later. So yeah, and it's great for domain modeling. Like once you know this and you really try it, you will never stop. And yeah, that's great. I'll show you more examples later. So with the coproduct, as I said, you have to do some kind of a switch to how to work with the coproduct to really distinguish the cases, and that we call pattern matching. It's something like, you can imagine it as a regex on objects or something like that. You basically say what's the pattern there, and if it matches the pattern, it will like execute the branch. So yeah, sorry, this is F#, but never mind. So you can see like that you have like the tuple, and you can say if the first one is 5 and the other one is nothing, do that. And we match like this. And the great thing about pattern matching is that it's usually exhaustive, which means that if you add another case, the code won't compile. It will tell you that you have to extend this functionality or a function to match it. So let's see the final example with the reader. Here is how it looks in C#, that you have the result, which is like the coproduct we have shown, and then you have the match there, and if it's line, then you process the line. If it's paragraph end, you end the paragraph, and you end it. And if new type is added, this code won't compile. It will tell you that there is not a match function which only takes 3 arguments. You have to provide 4 functions there, which is nice. And oh, I won't spoil this for you. I'll leave the F# there. Oh, shit, that's another F#. Yeah, I'll leave this to the other session. So something that really goes with the products and co-products is type safety. And also, again, this is not something special to functional programming. It's just we cannot lie to our callers in functional program because we cannot really mutate stuff. We have to return everything, so the types are more robust. So one thing with the type safety is domain modeling. So let's say you want to model this class job, which represents some background job, let's say. It has a state. It's either pending, in progress, and finished. Then it has some percentage of the progress and a result. So what's in the result if the state is pending? Or what's in the percentage if the state is pending or finished? Like basically the percentage should be always 100 when the job is finished, but it's not enforced on the type level. And the result also, like what's in the result? Yeah, probably null, but that leads to null reference and a $1 million mistake. So we don't want to do that. So how to fix it with the coproduct? We can basically say that the job is either in pending, or it's a progress job, or it's a finished job. And only like the cases have the meaningful data they should have. So the in progress job has the percentage because there it makes sense. In the finished job, it has the result because only there it makes sense. And in pending job has nothing, for example. And then you say that the job is coproduct of, like it's either a pending job or in progress job or finished jobs. And it's really nice because this is like a super nice documentation, and you can really restrict your types to only few possible valid data. So it's pretty hard to even have invalid data because the types themselves forbid a lot of that. And then you can use the coproduct and coproduct to combine them and build more types. So if you want to add a name, which should be in all of the cases, you just say that you have the job state, which is the 3 cases, and the job itself has state and a name. And you can see how like the product and the coproduct composes, and you can basically build everything. And that's not a coincidence. You can build everything. That's why they are called algebraic data types. You are good to go with just a simple type I will show later, and you can build any type in the type system. Another thing about type safety is code deduplication. So let's say you have these 2 functions. One creates a date from 3 integers. The other one returns a calendar for a given month. So the proper implementation of both of these functions should be like this, that you check if the input is valid and you throw an exception if it's not. But this makes the code basically duplicate. If we introduce like the month just as a special type, we say it's a product of integer. We make the constructor private so nobody can really create it. And then we have a constructor. This is called smart constructor usually, which checks the input only in a single place and returns the month to the world. And then everybody can use the world and rely on the value being correct. So this would not be the proper implementation in a functional way because we have exceptions and stuff like that. But it keeps the information in one place. Another thing, this is just an example on how to model it because actually the best way to model a month would be as a coproduct of 12 stuff, right? It's either January, February, March, April, May, and so on. But for stuff that has let's say infinite amount of values like email, you cannot really say that email is either a@gmail.com, b@gmail.com, and everything. That would be the ideal way, but that's not possible. So you make this compromise that you say, okay, I will guard the value for you and guarantee that when you have the month or the email, you have a correct month or email there. And then we can change these methods to really take only the strongly typed types and not care about them being correct, but just being them correct together. And then the date holds the invariant that they together form a proper date. Another thing is like that the function has an honest signature. That's the no surprises part. Because for this, it gets a person from a database by ID. What does it return when there is no person in the database for that given ID? Now, sometimes. Sometimes it throws an exception, right? You don't know. You have to look into the implementation or in the comment to see that. And we know how it goes with the comments, right, in the end. So that's not nice. What we can do, I'll talk about that later, but there is this type. We say that the function returns an option of person. It says that it may be the person is there and maybe not. And we are forced, we can nicely see on the type signature what really is the function about. That's, we call that making the function total, that it has a result for every input, basically. Yeah, and one really good thing that we usually do in functional programming is that we prefer to put more decisions in the caller over the callee. Callee does not know the use case. He does not know what's happening. He should just return the information to the caller, and he will decide what to do with that. We'll see that more later even. So yeah, here are the special types I want to talk about. I'm not sure why they were not there. But yeah, so there is this special type I want to mention. It's called unit, and it has a single value. It's it has only a single thing. It's not useful. But why is it useful to use it? So you have this function versus action. Why do we have it? It's the same stuff. It just does not return anything. So basically, you can say that a function that returns a unit is an action, and you can really get this deduplication of generic stuff versus not generic stuff gone because you can only put the unit there, and you know it does nothing useful. And another special type is called nothing, and it's a type that cannot be created. And why is it useful? Well, some functions do return nothing, right? For example, this function, it will never return anything. So you can know on the type level that this function won't return you something. So you can, for example, have a function like fail.contract, right? That you basically say here it went wrong, and it should return nothing. But the semantic is not supported by C#, so it will still force in lambdas put the implementation, even the code will not ever be triggered. Yeah, so let's use, this is the basics, and now we can use the stuff we have learned to actually build stuff or do more. So one thing I would like to introduce you to is option, and I like to start with this following code. It's something. It's pretty random code. It adds a 5 to the input, and then it tries to divide it by 42. And yeah, and the code is pretty noisy. Who likes this code? Nobody. So what we can do about it? Let's see. We can refactor it like this. Who likes this? It's better, right? But it still misses something. What's bad about this is that we basically made all the preconditions in the one place, and then we have the functionality in a single place. But what if there is some precondition edit? You can easily forget to check it, and yeah, that's not nice. And as a programmers, we do forget stuff. So what we can do is to introduce this option, and it's a coproduct of, it's a generic thing. It's a coproduct of T something or unit. So it's basically a nullable type. It says either there is some value or there is basically not nothing, because nothing is really nothing. There is unit, which means the type is not there, it's null basically. And why is it useful? Because we saw that on the coproduct we have the only way how to work with the coproduct basically is via the match, where for the coproduct of 2 we will have 2 cases, and it will never ever let us write a code which does not state what to do if there is null. So no null reference exceptions. Yeah. Yeah, so now we can use it, right? We can, sometimes the option is also used for making the function total. So for example, division. Division is not total. Division is not an operation which takes two integers and returns an integer. It's an operation which takes two integers and maybe returns an integer, right? If the other one is not null. So we can write this function. So we say like divide. We say that if the b is 0, the match here is basically like a switch. We say if it's 0, then return an empty option, like nothing was there. In the other cases, just divide it. It's okay here. And from now on, nowhere in the application you have to think about when the division can fail. You just call it and you behave based on the option. And then we can compose it. This is basically the same function as on the previous slides. Who likes this, the letter function?
It's less readable from the very beginning.
Yeah, exactly. It's less readable when you don't know it, but you know it. It's like this. Who knows IEnumerable and select many? Everyone. And actually, it's the same thing. Option is just an IEnumerable of 0 or 1 element exactly. And in the map, as you can see here, it's the select. And the flat map is the select many, because we have the input like it's an option. So let's say it's an IEnumerable of integers, or a single or one, like none integer. We select it. We select all the elements there. We add a 5 there, right? Now it makes sense. Then we have the division, which returns an option also. So it's the same thing as it returns IEnumerable of something. So we have to select many on that. And then get or else is basically a function which says if there is no element, return this. So and it's really nicely readable, and you cannot forget about the error handling in this code. It really forces you to do it like this, and when you get used to, it's really readable. Actually, some smart guys in Microsoft thought that it would be nice to write SQLs in C#, but they came up with something that's known as a do notation in functional programming. C# programmers call it LINQ, I don't know why, but you can use LINQ on all the types that have select and select many. And there is a lot of types that have select many semantics. We will see some more later. And you can use it. So when you have basically two options and you want to add them, the implementation can look like this. So imagine that instead of the from keyword, imagine var. Instead of the in, imagine equal sign. And instead from the select, imagine return. Now it's just a simple code. So we can use that instead of the first example where we need to flat map. It gets messy. The LINQ can help us to solve that. And yeah, this takes some time to get used to, but the benefits are really huge. So error handling. So the options show us a bit about the error handling. But what if we want to know why it failed? The option only says it failed. That's not really useful. We want to add some information. So yeah, this is some code, which is, I guess, usual for some code bases. You have the sign up function, which takes credentials, returns an account, which is of course not true, right? Create signatures, sign up email, which takes an account and returns an email. That might be true, but we don't know. And then we have this try catch, and for all the cases that happened, we catch the exception and do something. What if if I would just ask you, in your code base even, what can go wrong with the sign up? You don't know. You would have to look into the code, and not just into single function. You have to look in the whole tree of functions, and maybe even the ones called from the .NET base class library. That's not nice. So basically, when someone extends somewhere in the call tree you called some exceptions, you will forget to add it here. So we don't want that, and also we don't want statements like the try catch, right? So let's fix it. So let me introduce itry or try, which is just a coproduct of two. It's just an alias basically with some like nice functions. And let's fix it. So we can then define an enum, like a sign-up error. We state everything that can go wrong. So the account already exists, the email is invalid, the password is too short, or there is even no connection, like to some third-party service or something like that, or to the database, if you want to handle that. And yeah, so notice that basically enum, this enum is a coproduct of 4, where all the types are units. They are just nicely named. And then we say that basically signups either returns an account or some signup error. On the type level, we have it given. And now when I ask you what can go wrong, it's super simple, it's right there. And then the create signup email, for example, has no problem. And then we can do also, like the map is the select one is the flat map. So we can do signup, and we have like the try of account and signup error, and then we map on the account only. If it's like okay, it will go through. If not, the error will stay there. And what's also nice that in C#, then like the consumer of this will basically match, yeah?
But how do you know, like, you put it in a signature, I try with account or sign up error, so you got a core product, that's nice. But how you guarantee actually that sign up is calling some other libraries, and then some of them throw an exception that you don't handle. So it still can throw an exception, there's no guarantee as well, right?
Well, you can do several stuff to prevent that. Like, of course, with the libraries, you cannot, no, you have to wrap them up or like dig in the source code. But if you want, you can just forbid, you can write an analyzer to forbid a throw keyword. Or like,
you're using some third-party stuff.
Yeah. Yeah, you have to write a wrapper, like if you,
but yeah, you can write the wrapper also in the previous case. So, like the sign up, if it gets try catch with the with the exception type, so catching everything. So you have it as well. You've got the same wrapper, so basically the same.
Well, it's not really, because like now you have the sign up error, and what the consumer will do, that's where we're heading, is that it will match on the I try. It will say like if it's success, do something. I have a nice code example maybe later, so maybe let's do the questions at the end and I will go back to it. Maybe it will make more sense with the context of the whole presentation, because I will revisit this idea. Yeah, so yeah, the errors are strongly typed, and then when you match on the error, it will like on the match on the enum, it won't force you to handle everything. So that's why ideally you would either write a function and an analyzer, like talking about C# in F# is easy. But talking about C#, you can either write a match function on an enum and an analyzer which will check that it's exhaustive, that you handle all the errors, or you can use the coproducts instead of enums for errors, and there you have a guarantee when you add the error case that you have to handle it. Yeah. Yeah. So we can also like combine that when the create signup, you will also return some error. Now this is more real-world example, because then when the functions return a different error, you basically have to create another error and map it to the common error. So you like call signup, then you map error to create the common error, and then you do flat map with the create signup email where you also map it to the common error. This is like this is something that people don't do with exceptions, but should do anyway with the exceptions, because like you should only talk about errors like within the layer which makes sense. So, for example, signup should never throw an exception which says file not found, because that's like it doesn't make sense. It exposes the internal implementation. You should catch the file not found in the implementation of signup and throw a new exception which makes sense. Like for example, your user is already there or something like that. Yeah, the weakly typed variant is not true anymore in the new version of func#, so I'll skip that. But you can convert your code base slowly with using I try of anything and exception, and slowly like restrict the error type to have less values and get there. Yeah, then validation. So basically, functional programmers say something like don't validate, just parse. I'll showcase that. So the validation is basically when you get an input, you want to return if it's good or not, but usually you want to return like everything that was bad. So if a user fills up a form, you don't want to say like the first name is bad, then he will resign up, the last name is bad. You want to give him all the errors at once, and I have seen some implementations of that, so this is the one. Who likes this one? Who did it this way already? A few hands. That's not nice. And the try can basically solve that for us. So when you have a try of we are creating a person here, right? Yeah. So when you have a try of a person and you have like an error array, and you have these like simple functions. This is like a create email, or it should be more named parsed email, which takes a string and returns the itry of email or the errors. Then you have the create name, which takes a name. This is like a simple implementation. It returns this. And then you have this nice function called try aggregate. It's usually called apply in functional programming generally, where you like give it a set of functions, and then the last function which says like if everything went okay, I'll execute this function. If not, I will aggregate the errors and give you all the errors at once. And like compared to the previous example, this is super nice.
You could just link here as well.
Yeah, you could basically. Kind of. Yeah, so we are getting more to the end. So this is some more like bigger example of how the shift of the object-oriented code can be made in C#. So let's say this is some endpoint in our code base. We retrieve the person by ID. Then if it's null, we return HTTP not found. Then we try to do something. If something happened, we return bad request. Otherwise, we return OK. This has all the bad properties we have talked about throughout the talk. And I'll put like everything together to how it can look like. As you can see, the code really shifted to just few lines. That's usually what happens with the functional programming. And then you can see how the types of the operation changed. So get by ID does not return like the person, but option of the person. And the do something returns itry of a unit because it's like a void function, so it returns nothing really interesting for the caller. And then you have the person, you get it by ID, then you map it to do something, and then you are forced to match on like everything that happened and decide what to do with that situation. So if the person was there and the operation was success, it's like HTTP OK. If there is one error, you can do bad request. If he wasn't there, it's HTTP not found. There are various ways how to write it. So this is one of them just to showcase you how to use all the stuff together. Yeah, and then there is this question. Pure functions are nice, but I have a database, right? My customer does not want a program where he puts like something, it computes something and returns 42 and that's it. I want a meaningful program that stores stuff to the database. I want forms, and basically most of the applications are just crude. So what to do with that? And yeah, that's the hard part. In functional programming, they say like, yeah, the state is the hard part, so do it as least as you can. Most of your application should be pure, and only at the edges you have to do some like I/O or stuff like that. So basically from now on we were designing the application or talking about how to write it from bottom to up. We were talking about the function level and methods, but now what about the whole application, how to write it, what to do with I/O. And like it's pretty hard, but the simple way is something that Mark Seaman calls unpure sandwich, which does not always work, but it basically means load the data, process it by a pure function, and then save the data. So most of your like pipeline is pure, just the edges are impure, which is nice, but it's not always applicable, right? Imagine that there is if like in the computation that you want to load just this or that. That's not always applicable, but if you can do it, this is like a good start, maybe to do it on some places. But then it gets a bit hard. Then there is like this thingy, the type called IO, where you basically, the function states on the signature that it's an IO function. It will do some IO operation. So here, like the getRecipe function takes an environment and the ID and returns IO of the recipe. Oh, it should return IO of option of recipe. But it takes a split. It basically, the only thing it does, it states explicitly that it's an IO function, that it will do something nasty. And then you basically know that most of your code is pure if the IO type is not there, because you cannot really, like, you cannot pass the IO to your pure functions. Yeah, so that's something. Then you can use the link queue with it, like this, because there is also with the thing with select and select many. Shit. Yeah. Then we can also improve it, because here, as we can see, we have like the environment passed all over the place. That's not nice. We can use a reader for that. Well, like this part, it's only because I don't want to leave it up you with the question, and what about IO? But really, like, you should not worry about the IO until you know like the basic stuff. This is really not something. This is not the main topic of the presentation. I just wanted to give a sneak peek of how it's solved in the big picture. Then you can use the reader, for example, to clean up the environment. Then you can see the environment is not there. There is a library called C# monad, which will allow you to use that. This is not in func#. Yeah, then you can take it to the like super level. There is this super famous library called Zio. Who knows Zio? Yeah, I knew that you. Okay, it's a Scala library, and it basically takes the IO and the reader and task and everything together and creates this big type, which you can use, which is super nice. Yeah, and there are also some alternative ways. They are called like free monad. I scrubbed it should not look like this. Okay, basically that you build up your, yeah, what's nice about IO is that you have to execute it in order to do something. So you cannot really do the IO operation in the function. You have to return it to the caller and he will execute it. That's why he's forced to know about that. And so then your program is basically a function that gets executed on the top. The alternative way is to basically build a generic data structure. You say that, for example, your repository is a coproduct of get user by ID and stuff like that. And then you compose it and you make like the base data structure, which is just a description what should happen, and then someone else will basically interpret it and execute it. Yeah, Mark Seaman has some nice like talks about that. Yeah, here are some links, and that's it. Thank you for your attention. Now I guess we have time for questions, I hope, or if there are no. Yeah, so questions?
Like, as an F# fan, I'm saying why, like, I see all this effort because, like, we don't want to teach F# because it seems like a sort of like an extravagant language. But wouldn't it be, like, I feel like for many simple cases, actually F# is kind of simple. So wouldn't it be actually easier to teach like C# program a little bit of F# and just use reference and F# assembly and
okay,
do whatever.
So I'll repeat the answer for the live stream. Yeah. The answer was that it's not easier to use F#. Always get this question, like always. So thank you for like filling up the sheet today. Yeah, as I said, it would be nice, but for big code bases, like our code base has 500,000 of lines. Rewriting to F#, good luck. It's not possible. And even the creator of language extensions, everybody asks him like, what the fuck are you doing, man? Like, this is so huge, just go to Haskell and leave us. And he was like, yeah, but I was forced to do C#. I have a big code base, it makes money, I need to maintain it, but also I want to put the functional principles there. So yeah, when you are on a green field, you have a small team and some skilled functional programmers, go with F#. But it's like, as we are taught in programming, that you should have your own toolbox and use the right tool for the right thing. When the F# is not possible, or not a good like fit for the project, this is a nice way how to incorporate some of the stuff in C# and stay sane even in C#.
Because yeah, I get that you don't want to rewrite everything, but like you could just rewrite super small steps and just have like assemblies, for example, for I don't know,
Like with F# it's a bit easier that it has the interop with .NET and stuff like that. But still, like even from the hiring perspective, if you write that you work in F#, people won't apply because they don't know F#. But if you write that you do C#, they will like, yeah, I know C#, that's okay. And then they slowly like get used to it because like learning another language like F# and learning these principles is a lot to have on a plate. But learning these principles in a language that you are comfortable with can be much better because you are like good with the language and you can nicely understand the principles from the environment you feel comfortable with. And so you can even use it as a step. So let's say you have a company which has multiple projects. You can have some projects in the C# for like juniors, mates, and then the seniors have projects in F#. Yeah, so I hope it answers your question and you get. Yeah, so it's nice to have it in F# or like that, but it's really hard to hire guys to do F#. Like I'm not sure about the Amsterdam, the state of here, but in Czech Republic, there is this F# meetup I go to, and that's basically like all developers in Czech Republic that do F#. I don't know, 20, 30, the few tens, like it's, and most of them are C# developers who are trying to learn F#. Like there is really few skilled developers in F#.
Yeah, because I feel like from the F# community, sort of that is sort of that we are fighting against ourselves when we, like, in a way, but.
Like, yeah, but as I always say, like the most known programming language is JavaScript. So like, world is out of his mind. So. Okay.
But isn't JavaScript considered a functional language?
Unfortunately, it is.
But unfortunately, you wouldn't.
The principles of functional programming are generic. You can use them in any language, basically. So, yeah, I just don't like JavaScript. It's my.
You wouldn't call JavaScript then a functional programming language.
Like, if I would be forced to write JavaScript in some jail or something, I guess I would be trying to use the functional principles also there. They have pretty nice libraries for, like, I think it's Lodash, Lambda. In TypeScript, they have TS, FS, so yeah.
But now to my original question, you said that there are few people applying for F# jobs. Why do you think that's so?
Are we getting philosophical? Well, like, my personal opinion is that it's not taught in schools. Like in schools, everybody is taught to do object-oriented programming, and you learn that, you make a lot of money out of that, and then people are not like good with changes.
I would say something there because you say object-oriented programming, but the opposite or the alternative to functional programming is not object-oriented programming because you can do object-oriented programming and functional programming. I think you want to say imperative programming.
Yeah, okay. That's a bit better word, like that imperative programming. But you can also write a functional code which is imperative, so it gets messy. But yeah, like people don't want to change usually, so they learn the object-oriented way, they make money with it, and like, why would I change?
I don't think it's the object-oriented argument, because you can do object-oriented with functional too.
Well, like in the bigger picture, yes, but in the scope of the whole application, that's not really possible. Like if you are designing the whole application, the object-oriented design, everybody is used to container, like dependency injection containers and stuff like that. That's not really a way for the functional app. So if you really want to have it functional, like the pure, like in Haskell, that's not possible. That's not the same. That's
so then you would say that skills are missing in the market because they're not taught by the schools.
I guess, and also functional programming, it's not coming from the bottom, right? When we started to do like programming overall, we did assembly, then we did a bit higher and higher, and we are going from the bottom. Function programming is going from the high, from mathematics. It's like it goes from a theory which is called category theory. It's a really abstract branch of mathematics, and like the concepts are from there, so it's getting like down. So that's also why people fear that, because it's like math and it's hard and stuff like that. You don't have to know category theory in order to be a functional programmer. It makes you a hell of a programmer if you know it, but you don't have to, and people think they do. So everybody is like, I don't have a PhD from informatics, I cannot do functional programming.
We have one more question here. Oh, if you could show your microphone. Oh, it's going to be fun.
Hello. This is, all right. Well,
It's especially for Henry. He is watching from Nigeria.
oh, hey. Hey,
Hi.
man.
We can also hear you.
Thank you. So my question is a lot more technical than these philosophical questions.
Yeah.
Did I understand correctly that when you can use try with with either one or two type parameters, and if the second type parameter is absent, then that means that it's either a success or an exception. Is that
The
correct?
try without the second parameter is something I forgot to remove from the slides. Because like in the previous versions of Func#, the try of just A was try of A and exception.
Yes.
Yeah, so yeah, I forgot to change the
So
slides
how
to that.
do we do it in the new version?
In the new version, you would have to explicitly say it's an exception that you are returning, which is not nice because it's
Oh, okay.
also it's try of A and like something and exception.
So basically, it's an either. What's in other functional languages
Yeah,
is called
try
either.
is either. Yeah.
Okay. Well, I like the one parameter option. It looked cool. Like that by default is
the
exception.
option still has a single parameter, but the try has two now to force people to put the exception there. We had like a pretty big experience with that, and we like decided to remove it for the good.
Okay.
Because you should not return exceptions, but some strongly typed error, usually.
I see. I think it's pretty clever.
Thank you for the question.
Cool. So is that correct understanding that you are using this functional paradigm at your work?
Yeah.
Right. And did you rewrite it from imperative style to functional programming, or did you just start implementing new modules in this functional programming?
So when our CTO 7 years ago started to make the code base, he first read a book about category theory. And so he wanted to write the whole code base in Scala, but that was not possible. Scala wasn't even production ready back then. And he was like, yeah, I will not like hire many developers. So he wrote it in C# and he wrote this like library to help him out. So in some sense, in the code base it was already there, but as we grew, we hired like developers which were not used to this way, and like as it was a startup few years ago, there was some code that was like made quickly, so it was more like object-oriented or imperative. So we are transforming like slowly the parts that are not there to the functional way. So yeah.
So what are the changes that you see when you go from the imperative stuff to
Less
the functional?
bugs.
Do you see any? Come again?
Less bugs.
Less bugs.
Because like if I don't want to steal more from your presentation, but when I write in F#, I'm pretty sure it works on the first time I compile it, because the types help you so much that it helps you really not to forget anything and restrict the types to a lot of. So when you have the try, you cannot really forget that this can also fail or this can also fail. You're really forced to program around all the use cases, and usually that, in my experience, results in much less bugs.
So how would you compare in terms of size of the code base, in terms of development of a feature from imperative to functional, and then in terms of performance?
Okay,
Those are three
so
things that-
in terms of size of the code base, it's much smaller. I have seen code bases or heard about that there were in Java. It was about 500,000 of lines, and they rewrote it to Scala, and it was like 100,000 lines. It was like 5 times smaller. So the code is usually much less lines. So it removes a lot of boilerplate and stuff like that. In terms of performance, there is nothing like that. Functional programming does not have any like impact on performance. Like generally, I cannot say something about performance in such an abstract concept. With the immutability, as I said, it can either improve or decrease the performance. Sometimes people think the performance is worse, but it's not actually true. And you can, like the performant heavy code, you can have that like written in some low-level techniques to prevent it, but you should not like have it all over the place until you are writing a game or something. Then you are probably not gonna do that. But it has no like, there is not really some statement I could say that do not do functional programming because of performance. That's not true, definitely. Sometimes even it can help performance. So yeah. In development time, like that's also pretty abstract. I would say it's much less because it works. So in a way that you are forced to do more of the work when like writing the code, but then there are less bugs. So it also reduces the development time because then you don't have to fix all the bugs years later. And yeah, that's in my experience. Yeah, but if you have any other questions, you can talk to me after the talk if we have no time here now.
I would like to thank you for presenting.
Thank you. Thank you. Thank you.